Hello students, I am Dr. Rajaram Dhok from Savitribai Phule Pune University affiliated Agricultural Development Trust Shardabai Pawar Mahila College Sharda Nagar Baramati. Let's start. Chemistry of F block elements lecture 6, nuclear fuels and their applications. So we see about the nuclear fuels. So before studying the nuclear fuels, we see the primitive fuels, means the man which is used for long times, and that fuels also give the energy, but energy obtained from that fuels are very poor, and so very small percentage of energy is released when they undergoes combustion. But when there is a progress of civilization of man, then man use some other sources like coal, petroleum, and these sources are comparatively give some more energy, but the energy obtained from this petroleum or coal, that is also very less than the nuclear fuels. So these nuclear fuels are more superior than this all other type of energy producing fuels. So such type of nuclear fuels are totally different from these traditional fuels or usual fuels, and energy obtained from these nuclear fuels, that is from the nucleus of atom, is at least million times more than the chemical energies or than the traditional energy fuels. So this type of energy, which gives very large amount of energy from the fission of the nucleus or from fusion of nucleus, that is called as nuclear energy. So this energy is liberated from the nucleus of the atoms. So we see the how that energy or how many energies are given. So there is one important equation which is explained by the Einstein, that is conversion of mass into energy. So that famous equation is E is equal to mc square. So here energy may be released in different forms such as light, radiations, kinetic energy, heat, etc. So binding energy and packing fraction curves that indicates that energy would be released during the fusion of nuclei, and also the energy is released by fusion of nuclei. So generally, if we consider the number, that is atomic number 56, then above the atomic number 56, when that element undergoes fission and it is converted into smaller particles, then at that time large amount of energy is produced. And in case of the smaller nuclei like hydrogen, when that smaller nuclei fuse with each other, then higher nuclei is produced. For example, when four hydrogen atom combines or fuse with each other, then helium is produced, and at that time large amount of energy is produced. So in this mechanism of release of energy, there is a fission of higher mass and weight less than the parent nuclei. The difference in mass is either case itself indicates the form of that nuclear fuels. So it is possible to release enormous amount of energy, that is near about 10 raised to 12 calories, by fusing hydrogen atom into helium. And it is also possible to release the enormous amount of energy, more than 200 million electron volt, by breaking the pieces of uranium 235 nucleus into smaller pieces. So by the breaking of higher nuclei or by the fusion of smaller nuclei, large amount of energy is produced, and that energy we can use for the peaceful purpose or necessary purpose. So here we see the reaction. In this reaction, here we see the uranium 92-235. So that uranium 92-235 is bombarded by neutron, then they are breaked into two smaller particles like barium and krypton. And at that time, again, three neutrons are eliminated and 200 million electron volt, that is near about 10 raised to 10 kilojoules per mole of energy is evolved. Or there is one other reaction is formed, that is uranium 235. When bombarded by neutron, then there is formation of iodine 138 and ytterbium 95, and three neutrons are also produced. In that, 2 into 10 raised to 10 kilojoules mole raised to -1 energy is produced. So in this way, here large amount of energy is produced when higher nuclei like uranium is breaked by bombarding the neutron. So these nuclear fuels, they can produce the energy, and such type of nuclear fuels are classified into two types. And one type is nuclear fusion fuel and second type is nuclear fission fuel. So we see one by one that both the types in detail with certain examples. So we see the nuclear fusion fuels. So fusion of lighter nuclei yields a more stable nucleus, and at that time large amount of energy is produced. So in case of the nuclear fission of heavy atoms like uranium 235, the nucleus splits into two nuclei, and at that time large amount of energy is produced. So mass is converted into energy, and by using that equation E is equal to mc square, here how many amount of energy is produced, that is calculated. So similarly, certain lighter nuclei that can be fused together and produces heavier nuclei, and this heavier nuclei, there is loss of mass and very loss of mass, and simultaneously there is a formation of large amount of energy, tremendous amount of energy. So here fusion of four hydrogen nuclei forms helium atom, and it results into the liberation of tremendous amount of energy. So unfortunately, there is certain problems. So this reaction is possible at very high temperature, and this temperature is several millions degree centigrade is necessary, and maintenance of this higher temperature is very difficult. And so nowadays such type of reactions are not practically possible to produce the large amount of energy, because with us large amount of hydrogen is present. On the earth, two-thirds of water is present, and that water means there is hydrogen and oxygen. So we have a very tremendous amount of hydrogen stock. But the minimum conditions required for starting this reaction is several million degree centigrade temperature. And nowadays this is difficult, and such type of technology is not developed now. So this fusion of the four hydrogen nuclei forms helium nuclei, and this can be given in this reaction. You see here reaction 4 hydrogen, it gives helium 24 plus 2 positron plus energy. So here same type of reaction is observed in hydrogen bomb. So that same reaction is in observed in hydrogen bomb. So reaction, if we use that same reaction for the useful purpose of the human, then we can produce large amount of energy, and that can be used for the generation of electricity and some other sources of energy. So here principle of that hydrogen bomb or thermonuclear bomb is based on the sudden conversion of hydrogen into helium. And the process of nuclear fusion is the source of stellar. So now there is sun, and that sun gives large amount of energy. And on the sun, such type of hydrogen reaction or conversion of hydrogen into helium is carried out, and due to that large amount of energy is produced. So in the neighborhood of the sun, the temperature is very high enough, and that nuclear fusion can take place to produce the energy. And because of that, sun powers out in the space large amount of energy. So typical man-made nuclear fusion processes involves the covalence of the nuclei of deuterium atom, and which is an isotope of hydrogen. So by using the deuterium, also the same reaction can be carried out. So you see here reaction 2H2 means that is the deuteron. It gives helium 24 and energy. So in this fusion reaction, also large amount of energy is released. So we can use the hydrogen or deuterium for the fusion fuel. So nuclear fusions, like the nuclear fission, that can be used to produce a power for peaceful purpose. So large amount of hydrogen that can be used as a substitute for the uranium fuel. So nowadays we use the uranium for the production of electricity, but there is limitation for the storage of the uranium or stock of the uranium. So such type of limitation is not in case of the hydrogen, because in on the earth large amount of hydrogen is available. So by using that we can produce the nuclear fusion fuels, and such type of large amount of energy can be used for the power generation. Now what are the advantages of nuclear fusion fuels? So this reaction in which nuclear fusion fuel is used, this is very cheap, because the fuel which is required is hydrogen, and that is readily available. Deuterium and tritium that can be used in that, and we also separate that from our ordinary water. So there will be no problem of disposal of radioactive products, and that is observed in the fission reaction. So from the uranium there is possibility of radiations or evolution of radiations, but such type of radiations are not in the fusion fuel. Then there will be no danger of exhausting raw material. So here raw materials are not produced, or it is not also the hazardous. And so such type of nuclear fusion fuels are the eco-friendly energy producing fuel. Now we see the second type, that is nuclear fission fuel. So when uranium 235 is bombarded with neutron, then uranium atoms split into two lighter nuclei, and that two lighter nuclei are nearly equal mass, and the change in that, or when that lighter nuclei is produced, then with that lighter nuclei large amount of energy is produced, and such type of reactions that is called as nuclear fission reaction. So here we see that how that nuclear fission reaction is carried out. So we take uranium 235, on that neutrons are bombarded, then they are broken into two smaller nuclei, that is one is atomic number 56 barium 139, and second is krypton atomic number 36 and mass 94, and three neutrons are produced, and 200 million electron volt energy is produced. Then second reaction, uranium 235 when bombarded by neutron, then some other product is iodine and ytterbium, and at that time also same number of neutrons are produced, that is three neutrons are produced, and 2 into 10 raised to 10 kilojoules mole raised to -1 energy is produced. Means by both the reactions large amount of energy is produced. So if we see the different isotopes of uranium, then Here, three isotopes, that is uranium-233, uranium-235, and plutonium-239. These three are fissionable and they can be used as a nuclear fuel. So remember again, uranium-233, uranium-235, and plutonium-239. These three are fissionable and that can be used as a nuclear fuel. So out of that three, that is uranium-233, uranium-235, and plutonium-239, only uranium-235 occurs in nature. And if we see the amount of that uranium-235 in the nature, then it is present in very small quantity. That is 1 part in 140 parts of natural uranium, that is uranium-238. So uranium-238 is the natural uranium, and in that uranium-235, which is fissionable, that is present in very small quantity, that is 1 part in 140 parts of uranium-238. And the other products or any other higher nuclei, they are produced artificially by the nuclear reactions in the nuclear reactor. So we see how that higher nuclei are produced, and that higher nuclei that is also used for the nuclear fuel, or they can be used for producing the higher nucleus, that is radioactive elements. So we see here that uranium-233 is produced. How it is produced? It is produced from the thorium. So thorium-232, it is natural material, but it is not fissionable. So they can be converted into the fissionable material like uranium-233. For that purpose, that thorium-232 is bombarded by neutron and gamma radiations are given out. So N gamma reactions are carried out on that thorium-232. Then there is formation of thorium-233. This thorium-233 is unstable nuclei. It eliminates one beta particle, and the higher atomic number radioactive element is produced, that is the Pa91-233. This protactinium-233, that is also the unstable, it eliminates one beta particle and it forms uranium-92-233. So in this way, that fissionable uranium-233 is produced from the natural material thorium-232, and for that purpose, here nuclear reactions are carried out. Now, we see that how uranium-239 or plutonium-239 is produced. So plutonium-94-239, its properties are similar to uranium. So that is also called as uranium-239 or uranium-94-239. So how it is produced? For that purpose, the natural uranium, which is not fissionable, that is uranium-238 is used. And on that, N gamma reaction is carried out. Means on that, neutron is bombarded. By bombardment of the neutron, there is formation of uranium-239. This uranium-239 is unstable. So immediately it eliminates beta particle and forms neptunium-93-239. This neptunium is also unstable. It eliminates one beta particle and forms plutonium-94-239. So in this way, by the nuclear reactions, the material or natural material, that is uranium-238, thorium-233, these are not fissionable materials, and such type of materials cannot be used as nuclear fuel. But we can convert that into that suitable form, and for that purpose, that uranium-238, thorium-233, they are converted into plutonium-239 and uranium-233. So such type of materials, they can be converted, so that thorium and uranium-238, these are called as fertile material, because that fertile material can be converted into that fissionable material. Now we see the nuclear chain reaction. How nuclear chain reaction is carried out. So in that breaking of uranium, there is a formation of chain reaction, and that is called as nuclear chain reaction. So how it is formed? So we take uranium 235. When that uranium 235 is bombarded by one neutron, then they are broken into smaller nuclei. They are broken into smaller nuclei, and in that smaller fission fragments are formed. So we have just seen there is formation of barium and krypton, and not only barium and krypton, but some other elements which is near to that barium and krypton they are produced. And at the same time, three neutrons are eliminated. Now when that three neutrons are again bombarded on the three uranium atom, then that every atom again break into the different fission fragments, that is barium, krypton, iodine, and every uranium also again eliminates three neutrons. So in this way, when one neutron is bombarded, then three new neutron is produced. When that three neutron is again bombarded, then nine new neutrons are produced. When that nine neutrons bombarded on the uranium, then 27 neutrons are produced. So in this way, this chain is continued, and there is formation of chain like reaction, and so that is called as nuclear chain reaction. And this nuclear chain reaction is not controlled, it is uncontrollable reaction, and when reaction starts, then it cannot be controlled. And in the nuclear reactor, for controlling, some other controlling materials are used, that is called as moderator, and with the help of that moderator we can control the reaction, and we can carry out the reaction as per the required speed.